Cis and trans isomerism is a type of isomerism known as stereoisomerism because the difference between the two isomers is an orientation in space, not a difference of which group is bonded to which carbon. For example, consider the two isomers of 1,2-dimethylcyclopentane. Each isomer has a methyl group bonded to the 1 and 2 carbons of the cyclopentane. However, considering the isomer on the left, one methyl group is in front of the plane of the molecule, or above the molecule, while the other methyl group is behind the plane of the molecule, or below it. The molecule on the right has both methyl groups behind the plane of the molecule, or below the molecule. This type of orientation is known as cis or trans. When two substituents on a cycloalkane are on the same side of the ring, whether both are wedges or both are dashes, the isomer is cis. When two substituents are on opposite sides of a cycloalkane ring, one is wedge, one is dash, the isomer is trans. When it is important to consider this type of isomerism, we include the orientation in the name. The isomer on the left of the slide is cis 1,3-dimethylcyclobutane, and the isomer on the right is trans 1,3-dimethylcyclobutane. Cis and trans isomerism is possible for alkenes as well. To determine if an alkene is cis or trans, draw a dotted line through the double bond. If the similar groups are on the same side of the double bond, it is the cis isomer. And if the similar groups are on opposite sides of the double bond, it is the trans isomer. On this slide, we see the skeletal structures for the cis and trans isomer of 3-nonene. There are 9 carbon atoms, and the double bond occurs on the 3 carbon. Notice the cis bond is sort of kinked, while the trans bond follows the structural ordering of the tetrahedral carbon atoms. Naturally occurring mono and polyunsaturated fatty acids are always cis. This is opposed to trans fatty acids, which are formed from chemically altering fatty acids. Table 4.8 of the textbook lists some common unsaturated fatty acids or fatty acids with cis double bonds, which includes their skeletal structures and some dietary sources.